Our next speaker, connecting to us very early in the morning from Alaska, is Rick Thoman. Good, Rick, you're here and you can present as well.
Thanks for having me. So this is just going to be a quick overview of the Alaska wildfire season in 2022. It's a very is a large season, and in some ways it was quite unique, and perhaps a wake-up call for things to come. Next slide. So here's the just what I want to cover here in our short time. Just some background on Alaska wildfire overall, what happened in this season, and then some of the the why of what happened in 2022 in Alaska. Next slide. So wildfire, of course, is an important part of the Alaska ecosystem. Basically, the current ecological configuration was established about 6,000 years ago with the spread of black spruce across large portions of Alaska. And since then, the wildfire regime that we see now has been in place. Of course, there's been ebbs and increases, at the century type time scale. But basically, we've got what we've had for about six millennia now. Most forested areas in the interior of Alaska, so that's the area between the Alaska and the Brooks Range, very insulated from oceanic effects, so it's the warmest area in the summer. Most forested areas have burned at least once in the last 500 years. And because this is a 6,000-year thing, here in the north, lightning is the predominant source of modern starts, at least when we look at the fires in the area that they burned. But people have always been in the mix in Holocene wildfire in Alaska as well. Next slide. So just like everywhere, we need a number of ingredients to come together to produce wildfire. So we need the air, the atmosphere to cooperate. We need fuels. We need stuff that can burn. And we've got to get a way to ignite those fuels in the appropriate atmospheric conditions. And then we can add on some things like wind and sun to help things along. And so in Alaska, the season, though, is really tightly bounded, particularly in the spring. Of course, over most of mainland Alaska, snow starts accumulating on the ground in October or early November, and then builds until sometime, typically end of March to end of April, depending where you're at, and then melts out. So getting that land to dry, the fuel to dry, is bounded by that snow melt. And then climatologically, mainland Alaska is really split into two seasons. Early summer, which is sunny, warm around the solstice, so continuous daylight. And then in late summer, typically sometime the second half of July or very early August, westerly winds start to increase as the sun decreases in the polar regions. And that's climatologically the wet season for mainland Alaska, especially in the fire-prone areas. And so that is a more flexible late bound on the season. Seasons, as we'll see, seasons that late summer rain doesn't come can be big wildfire seasons. And if you hit return again, as I mentioned, the interior of Alaska, so the area insulated from the oceanic effects, are favored. We get the highest temperatures in the summer. We get low humidity in the atmosphere is common in the early summer, in that the early dry part of the summer. And this is the area where lightning is most frequent during the early summer season. Next slide. So an important thing in boreal wildfire, and I know many of you know this, but it's really worth emphasizing, is that in the boreal north, the fuel for fires isn't just vegetation above the ground. Over much of boreal Alaska and northwest Canada, there is this this duff layer of undecayed organic matter that is of varying depth across the landscape. But this is material, plant material, it's undecayed or partially undecayed, and is very flammable. Not only is this a way, of course, for fire to burn in season, but the so-called zombie fires, the overwintering fires. This is the fuel that they slowly consume during the winter. These under the snowpack, and they can sit and smolder, and in some cases, of course, return to life the following spring. So the fact that there's significant fuel below the ground is really important part of the wildfire puzzle in Alaska and the boreal north as a whole. Next return, there we go. So as I mentioned, in Alaska, while the number of wildfires, if you just count the fires in the modern day, say the last 25 years, the number of human starts and the number of lightning starts, it varies season to season, but typically they're going to be roughly equal. But as I mentioned, lightning starts the vast majority of fires that consume the largest amount of acreage. This year, for instance, more than 99% of the area burned was from lightning starts. It's not really too hard to understand that. Of course, human starts are where there are people, and so in general, those are much more quickly attacked and suppressed. The other important factor in Alaska wildfire season is that we have a very short season most years. Short but intense is the motto, and because of the climatology, it is really early season loaded. The character of the season is determined by what's happened by late June. Thereafter, it's for the most part, it's pretty well locked in stone. In the appropriate atmospheric conditions, if the summer rains don't come, we can burn through August and very rarely even into September, but those are going to be fires that start before early July almost entirely. There are very few examples of large fires that have started after mid-July. Next slide. So here is the plot of on the left, on the right-hand side, just the area burned since 1950 for Alaska. 2022, about 1.25 million hectares. There is the 7th largest season in the last 73 years. And the colored bars there are just seasons with more than 1 million hectares burned, and you don't need any statistical analysis to see that those have become much more frequent in the 21st century than before. Now, just to get to any question there, there was a change in wildfire suppression policy in the late 1980s in Alaska. Prior to that, the standard U.S. policy had been to suppress everything, and that changed in the late 80s to more ecologically balanced. However, there's been multiple papers and work done, and the opinion of the fire managers in Alaska. While that was the policy, suppress everything before 1986, there was never anything like the resources to be able to do that. And lots of research has shown that it's had no appreciable effect on the large scale area burned in Alaska near human settlements. That's where most of the suppression activities occur. Now, in this season, very intense, about 95% of the 1.3 million hectares burned in 6 weeks. Southwest Alaska was really the area with extreme, unprecedented wildfire, really quite, really nothing like it in some regions in the last 70 years anyway. And we had a lot of smoke, and during this intense season, it was quite extreme in places. Next slide. So here's a plot of all the fires in Alaska in 2022, and just some place names there that you might recognize just to orientate yourself there. The area boxed in there in Southwest Alaska, as I mentioned, is really the unprecedented area. In that area there, we had more wildfire this year than any other region. And that area in the southern part of that box there, in that Bristol Bay region, there were several very large wildfires. In fact, in that area, they burned more acreage this year than 1950 to 2021 combined. You also see near the upper left-hand side of that box, there's two quite distinct perimeters there, just north of the Yukon River there. One of those, the East Fork fire, was the most impactful fire, was very close to 4 communities, required some evacuations. The East Fork fire and the farther northwest one there, the Poon Pass fire, those are the 2 largest tundra fires in Alaska since 2007. So really quite a remarkable time here in Southwest Alaska, a region that historically does not get that much wildfire. You hit return there. So those are the points I just covered there. Again, we have pretty decent acreage estimates, and especially for big fires, we got good records going back into the late 1940s. So we can be confident that we have not seen anything quite like this in that time frame, certainly in the post-World War II era. This year was really unprecedented in that Southwest Alaska. In return. So I mentioned that one of the characteristics of our fire season here in Alaska is this very, very short season. And these are just some examples of big seasons and how the acreage accumulated during the season. These are from the daily estimates from the Alaska Fire Service. This year is the dotted greenish line there. The most outstanding feature of this is we burned a lot of that wildfire in Southwest Alaska in early to mid-June. As far as we can tell, we burned more acreage in June this year than any year, at least going back into the 1960s, when we have any estimate of near daily acreage, unprecedented early season growth. But you can see there that by the time we got to mid-July, we had a hard stop as the weather pattern changed. It's not like that in every year, but this hard stop is not uncommon sometime in the second half of July. Next slide. So East Fork fire pictured there. Communities and cultural resources are the main things that are protected in this day and age, and realistically, that's always been the case. Next. So we had 3 fires that posed major threats to communities or people directly, residences, and those are listed there, and did lose at least 1 or 2 home structures and lots of outbuilding type structures as well. Next slide. We burned a lot of biomass. Anytime you're going to build 1 million hectares, of course, burn that much area, you produce a lot of smoke. There's a nice image there from the NOAA 20 VIIRS, and I've annotated that. And you can see the smoke here on June 30th, covering a big chunk of terrain, locally extremely persistent and extreme. Next slide. And here in Fairbanks, we had more than 440 hours with visibility of 6 miles or less in smoke. I like to use this. This is from the airport. This is a nice, it's not, the visibility, of course, is for aviation purposes. It's not related to changes in technology. And so it makes a nice time series here that's independent of the fire record per se. And you can see that this year, using this criteria, 6 miles is roughly the unhealthy air quality, and second highest in the last 71 years, and 16 days with EPA unhealthy or worse air quality in Fairbanks. Next slide. But Fairbanks wasn't the only place. The interior wasn't the only place with smoke. Explosive wildfire growth in Southwest Alaska on June 30th into the early morning hours of July 1 produced about almost 100-kilometer fire front. And the meteorology was such that it transported this dense smoke from this fire front far to the northwest. And pictured here is in Nome, about 750 kilometers from the fires that were producing the smoke. The meteorology trapped the smoke in the lowest couple thousand meters of the atmosphere and transported it northwest. And we had this unprecedented dense smoke very, very far from the fires. As we saw in the last presentation, this smoke transport is a big deal and can really be extreme at times. We saw that this year. Next slide. Just to wrap it up here, why did we have this? We had we had deep snowpack across portions of interior Alaska, but Southwest Alaska had a lower than average snowpack in April. And then, next slide, combine that with extreme dryness during the spring. Spring is already the dry season over mainland Alaska, but this was exceptional even for the spring. And so, especially in Southwest Alaska, early snowmelt, dry, was also sunny. It was significantly warmer than normal. And all of this combined with unusual lightning in Southwest Alaska in late May and early June really kicked things off. Next slide. And here's the lightning plot. This could have turned out a lot worse. Lightning was above normal with a big strike peak there in the interior and east. That occurred right before the change in the weather pattern that brought the rains in. And so while the Southwest Alaska strikes there early in June don't look as impressive, they occurred at the right time of the year. The strikes that came later didn't have time to go because of the pattern change in the weather, which is typical for mid-July. Next. And you can see how that spreads. The lightning, focus of the lightning changes. Next slide. And as I mentioned, the pattern changes there in mid-July. It's not like it had been continuously warm, but in early June there, when it got cooler, it wasn't rainy and cool. It was dry and windy, which of course with fire on the landscape really helped kick things off. And then the end of the season, rains came as expected. Next slide. So that is what I have for you. We do have a nice publication out on Alaska's changing wildfire environment that's available from the International Arctic Research Center website there. It's a very nice publication. And if there's any time left, happy to take any questions. Thanks.
Oh, thank you. Thank you, Rick. That was great. I think we have just time for one question. You have several questions in the Q&A Google Doc. And I do think this publication you just highlighted, some of the questions may be answered there. But there are two questions around lightning. So how do you determine whether the fire in Alaska was ignited via lightning or from humans?
So that is a good question. And so we rely on the Alaska Fire Service to make that determination. In many cases, there's lightning strikes detected in the vicinity of where fires are discovered. And in most of those cases, they're going to be very far from communities. And so that's the Occam's razor is we've got lightning in the area. It's not close to where there are people or easy access. And so it's assigned as lightning. Okay. In most of Alaska, it's fairly clear.
But you're not using satellite products or maybe like commercial lightning modeled products necessarily.
No, the Alaska Fire Service since the late 80s has maintained its own lightning network. That changed radically in 2012. Nowadays, in the last decade or so, there are more lightning networks, global networks that are available, but fire service is still using their own.
Okay. Well, that's very interesting. Sounds like there might be some analysis there to think about from different sources of lightning, right, to
Yeah,
determine fire.
it's a hot topic.
Yeah, no pun intended. Well, I think I want to thank you again.